Welcome. Today we will demonstrate how 3D printing works. We have our app called 3D printing driver app. We will demonstrate how we do 3D printing. Uh, 3D printing is a emerging technology that is emerging into market for 3D printing 3D objects. So any objects currently in the technology market, we have medical field application. In the medical domain, we do a lot of 3D printing for dentist, orthopedics, orthodontist, bones, etc. Apart from this, we have jewelry making, and it is now diverging into different markets. And in fact, civil engineering field also, it is going to be a great application, like for construction of buildings, hotels, malls. So this is the app driver that drives the 3D printer. So we open a new document. It starts with a bounding box. We have this bounding box where we will build our model, where we will 3D print our model. The application has some windows, data viewer and see data viewer. Then we have property viewer on the down left dock. Then we have printer control widget, which is responsible for basically driving the printer. So and finally we have the console view. We have the console view where we'll get messages, and serial console will get messages for understanding different uh, things, for understanding the current state of printing. So this is supposed to be a dock widget. Yes, I don't have the source code right now with me. That is a problem. I can't modify it. So we have it this application standalone. Let's not make the serial console here, and message console also we can omit. Property viewer is also not much of necessary, so we remove the property viewer. You can see on the right hand side the printer control panel. We have the connectivity where we have serial port by which we connect our machine device. COM7. Currently I don't have any machine with me, so I cannot show you a full 3D printing event, but I can show you how we do it in modeling side of point of view. So if we have a printer, it will come here. Once we connect by USB port, it will come here as COM7. We select it, baud rate, data bits, parity, score, stop bits, flow control parameters we have to select, and then click on connect. It will connect the printer. Then we have user variables. Then we have user variables. We have here layer height, how much how much thickness we want for each layer. Then recording extraction speed, number of layer shrinkage. Shrinkage is an important parameter which we lose the material during the printing process. So to give the percentage, will we it is an experimental value. We have to try and see it varies from material to material, and from application to application, dip, retraction speed. These are all experimental values. You have to try and see. So but we have standard values for our printer, so there is nothing to worry much. Certain values are very standard. So layer height is in general 25 micrometer, which is two times thicker the piece of paper. A piece of paper is 11 micrometer. Piece of standard paper, printing paper is 11 micrometer. So two times more or less thicker than the printing paper. So it is 25 micrometer. So we are printing very fine uh, thickness object. So we have functionality here: play, pause, stop. These functionalities I could have shown you if I had a printer, but I don't have a printer right now, so I cannot show here. But I can show you other features like so let's start loading a model. It will be a STL model. It will be a STL file. So we have STL file. So let's start with various models we have. Let's load a A380 Airbus 380 model. So you can see it is Airbus 3 A380 model loaded on the build plate. This grid plate you can see on the bottom is called the build plate. So shift left mouse is for panning, wheel event is for zoom in zoom out, and then left mouse is simply rotating, 3D rotating, 3D rotation. So you can see the model is loaded here. It is Airbus 3 A380, the biggest commercial fleet, the largest, biggest in size. So what we do here, we do slicing of the model layer by layer, right from bottom to top. So we have certain features here. We'll not do slicing in general because slicing happens during printing process. During once we have the button here called print. This is disabled now. Once you connect a printer, it will be activated. It will be green light, and you can press on it. It will start to. You have to do nothing. Basically, just to load the model and straight away doing some parameter changes and print. That's all. For visualization purpose, we give slice view here. You can see slice view, and this is 3D view. So once you click on slice view, it will show you the slice view. So at the same time on the status bar you can see slice number 1 being processed out of 331. It will also show that how many slices are generated. There are 331 slices generated, and what you are seeing is the slice number 1, the most bottom slice, which is having a wheel basically. So these are just two wheels, two wheel sections. So if you like to see these particular slices 3D view, you can click on 3D view, click on 3D view, and it will show you what you are basically seeing in the green light. Can you see the green light on the two sides? You can see the green line, green circle. That is the slice number 1 on the both sides, engine's bottom side of the engine, right? So then again go to slice view. Once you go to slice view, you can see this. Then if you want to go to any number of slice, you know how many slices are generated on clicking first time on the slice view, 331. So let's see 10 number slice. Once you click on 10 number slice, it will show you 10 slice. Once you click on 100, it will show you 100 number slice. And enter. You have to enter. So this is the 100th slice. And if you see the 3D view of the slice, you see which part, the fuselage, wings, some part are coming into. So this is basically, this is a mathematical computation we do with the model section, and we are putting a section, plane section on that particular layer height, and cutting the whole model with the section and extracting the section, extracting the cross section from all along the body parts. So we have hollow and solid. You can see the white color is the solid, and dark black color is hollow. So this way we distinguish hollow and solid sections. So we have our mathematical kernel which we use, which we developed for computing these sections and these cross sections, this mm, and then if we now if you give, we have 331, right? So let's give 200 and enter. You will see that 200 number slice is in green light. It is part of our radar, and once you select on it, it will come yellow. Deselect, you have to deselect it, so it will come this. We have some on the model. If you click on model, right mouse, you will see the you have to select the model just by clicking right mouse, left mouse. Once it is highlighted in yellow color, you will, it is means it is selected, means it is selected. And after that you will get these options, wireframe. You can see the wireframes view. If you want to change color, go shading, you will see shading. Then we have delete option is also there, it will be deleted. So this way we visualize the cross slice. So 331, if you give, the last slice is the tip of the radar vertical stabilizer, tip section of the vertical stabilizer. So it is under selected mode. You deselect it, and color will be retained. You last change color. If you change the material and shading, it will be retained as last. If you want to change background color, you can change. This way we can change background color. This will show. If you want different background, just change background, green. So this is how we do diagnostics on the model. And then now the interesting part of this application is that not only one, if you want to load multiple models, you can do that. At a time we can build as many number of models as we want, depend by changing the size. So let us load a Eiffel Tower. So you can see a Eiffel Tower is loaded on top of the aircraft. Now it is looking very big, right? So we can do many things. You can reduce the size of Eiffel Tower, and we have the transformation feature here. Just load the transformation UI. And what you want to do, you want to scale. Let us reduce it to some size point. Scale 1 means the default size, and anything fraction means it will reduce the size. So you can see the size is reduced to some reasonably compatible with the aircraft size. Then you place it centrally on the model. It is placed centrally. Then you do some transformation on the right x-axis. Let us do on the x-axis, and it will move on the right hand side. Move on the right hand side. See, it is moving on the right hand side. Then you select the aircraft. Select the aircraft, and let's move it on the left hand side so that they'll sit right beside each other. Let's select the Eiffel Tower again, and positive x-axis to move right. You make sure that the model doesn't intersect the bounding box, because if it is intersecting the bounding box, or it is getting out of the bounding box, it will not be printed. If the bounding box is the volume, is called a print volume. So this is the print volume within which you have to keep as many as models you want. That doesn't matter, but it should be within the bounding box, right? Now the interesting thing, one more interesting feature, is that you can slice both these together, right? Otherwise it doesn't make sense to print the models. Now if you go to slice view, it will recalculate, and you can see it's giving an error here in giving message. Let's go to 100 slice, and you see both both of these models slice. You can see fast 100. You can see this is the part of the Eiffel Tower, and this is the aircraft. So it will give you the slice of the whole, all the models within the print volume. So at a time when it is printing, that layer, everything is printing. So your model, your aircraft is also being printed, and your Eiffel Tower is also being printed at a time. It will maintain the and if you go to 3D view, you can see both of these parts are in green light. So these are the features we have in our printing driving driver app, and it is compatible with any SLA stereo lithography based printer, DLP printer. So now once you're once you are done with the synthesis diagnostics of the model, once you're done with analysis and modification, slicing, then everything, then you click on this print. It will start printing. Another important thing is that when we have overhang parts in the model, for example this aircraft, it has wings. You see, these are overhangs. These overhang things are very difficult to print, because by the time it will cure, it will fall down. It will fall down for the before the next layer starts. So that will be a problem. So for that purpose, we give supports for the overhang sections. So for that, we do support generation. You click on support generation and keep the model, and here we have some of the controls. This is exit, this is exit. Once you click on it, it will exit. So exit, we have these features. Now we have these are the manual things, this plus, and this one by one support creation. But this is the generating automatic support. It will calculate automatically the slope of the overhang part and keep generating the supports. So it has an intelligent algorithm inside which computes the overhang sections and generate supports for each layer. So at a time we are computing two layers at a time and trying to predict the whether a support is needed or not. If needed, keep it, give it. If not needed, skip. So just you don't have to do anything, just click on generate automatic supports. If I start clicking, if I click on it, it will start generating support. And the problem, I don't have the source code right now, otherwise I would have modified. Because 25 micrometer layer height is given, by default it is taking 5 micrometer as the uh, offset to compute the support. So it will take a long time, right? This program will hang, keep calculating and generating support. So I have nothing much more to show you here, so I am closing it here. I'll give you the picture of the support once it is finished. So just I'm closing the session here, and later I will post the support picture how it looks like. It will take some 1 hour time, in not less than 40 minutes to create the supports. It depends upon how many layers are there, but if we increase this layer height to some 2500, it will be less number of layers will be created, so it will compute soon. But since we have it here 5 micrometers, so there will be some thousands of layers. That will take time, so we don't have parallel processing here. We are trying to implement a parallel programming here to compute the supports and slicing. So soon that will be in the next version. But right now we have single 8 core CPU. So let us close the session here. I think you have seen all features. This is fit all. You click on it, it will fit on the screen exactly in the middle. So this is all we have. Now I will close the session and start calculating the support, automatic support generation. Printing process I could not show you. I don't have printer right now. Once I get a printer prototype, I can show you a and I can show you a video clip of how printing happens. So thank you for listening. I click on generating automatic support, and it's wait cursor. It started. You can see on the status bar slice number 22 and 24 processing. Total number of slices 1181. 1181 slices will be processed to compute the supports, and program will be still busy. So I will close the session now, and maybe I'll start. I'll show you the support picture. I'll post the support picture. If you want to wait, you wait, no problem. We'll also wait. We'll see how it happens. Currently 135, 139. So it will be till 1180 and 1181. At a time, two consecutive layers are being calculated and compared to predict whether a support is needed. You can see on the wings portion there will be supports needed 100%, otherwise wings will not be uh, created. So currently 250, it will be 1181. So wait. So now it is processing 790 and 90 one number slice. So today's 3D printer are 3D printers are very sophisticated to make industry models, industry parts, parts of aircraft, parts of engine, parts of body parts of fuselage, even civil engineering, buildings, hotels. So materials are the most challenging thing in 3D printing. So right materials and curing of the materials is very important. So plastic materials are basically cured by ultraviolet rays, UV lights. So 5000 milliseconds it requires to cure a layer by UV light. So we have UV light uh, holder in 3D printer, so it will be projected on the layer, and we will be projecting a slice at a time, and after creating the layer we cure it by UV light. So plastic materials and resin materials can be well constructed by 3D printing, and depends upon the size of the printer we can print big models, doesn't matter, only a matter of size and a certain care of certain features. So now it is 135, we'll have 180 and 181. The last slice will be processed 180, 1180 and 1181 slice, the last two layers, and after that it will be getting support. So you can see all around the wings we have supports created. So because wings are present, so it will be creating supports all along. It is not very intelligent to create correct supports, but it is an approximate solution. Even the support is not required, but it will be still creating supports if we create automatic support generations. But the most important part is that where the support is required, it will be creating. Maybe it will be creating some extra supports, wastage of materials, but still our actual model will be protected. So this is how supports generations algorithm works. So if you want to visualize the whole model, you just hide data viewer, hide printer control widget, and the whole screen will be there for you for visualization. Once the supports are created, then you are ready for uh, printing. Just click on it after connecting the printer machine, and it will be start creating the models. Thanks for watching. I hope you enjoyed it. So we'll close now.